Jody, what are you doing?
Just being nosy.
Oh, you can hear me?
Yes.
I'm gonna kick you out.
Does it make you feel uncomfortable?
No, not really, but I'll put you in the waiting room or something.
You should talk about the test first,
Why?
because I don't care about the pig. I'm just kidding. I don't know what kind of pig it is.
That's a lipid pig. Okay, we'll start in a couple minutes. We'll wait a few seconds. Okay, we'll start with the test, not because Jody necessarily wanted us to, but because I have it pulled up. I'll make it bigger. And so that way you guys can see it easier maybe. And so the test questions were random in the order you got them. This would be the order I saw them in, but I figured out how to grade the test more rapidly by doing a question at a time, so that made it faster. But this is how I wrote the test. So the first question that you guys had to look at was, what characteristics must a protein have for ruminal microbes to improve protein quality? Almost everybody, or a vast majority of you, wrote it needs to be a low quality protein. The thing you forgot was it also needs to be degradable. I tried to find degradability in everybody's answer if I could, and give them at least some component of the degradable function. But for the microbes to be able to improve quality, they have to be able to degrade it. If it's undegradable intake protein, they can't degrade it, and they can't improve the quality of the protein. If you have a question, you can stop me, or you can wait and ask me later or whatever. Okay, the next question, I think this question went reasonably well. Protein digestion begins in the stomach of the pig and continues in the small intestine. Please list the steps in something approximating an order. The approximating an order was more difficult than I thought it should be. Involved in protein digestion in the small intestine of the pig. Note the first step is the arrival of protein and oligopeptides as acidified digested in the proximal duodenum. Please do not describe absorption by the enterocyte. So a lot of people described absorption by the enterocyte, and if you described it, I graded it. And if you didn't describe it appropriately, I took points off. So it's very much in your best interest to try and answer the question that I'm asking rather than answering more question than I ask. And what you're really supposed to do basically is start with the S and I cells, detecting acidified digesta. You guys should have wrote in complete sentences. This is my answer is just for me to remember what I intended you guys to write. So I wanted complete sentences that made sense, or you could kind of make a list. The list would be good too, like if you had numbers. So either way was fine, but you kind of had to pick a way and stick to it. They act on the pancreas, causing the release of buffer enzymogens. They also act on the enterocytes to produce enteropeptidase. One of the things that a lot of people didn't do, and I don't understand why, is they would say zymogens, but then they wouldn't name the zymogens, nor would they have enteropeptidase activate the zymogens. So that was a little perplexing. So make sure you provide an appropriate level of detail. And if you didn't provide that, you didn't get hurt too bad, but still it wasn't probably what you wanted from a grade standpoint. And then trypsinogen activates everybody else. These enzymes break peptide bonds, enterocytes. Some of you did a really great job going into the detail about who does what, and I thought that was cool. So that was good. Enterocytes also release aminopeptidase, dipeptidyl aminopeptidase, and tripeptidase to hydrolyze the peptide bonds, resulting in amino acids, dipeptides, and tripeptides for absorption by the enterocyte. So that's kind of where I wanted you to stop. Okay. This one we struggled with as a class, and that was somewhat disappointing to me. I can look and see. Yeah, so this one we averaged 2 points out of 6 points, 2.44 points out of 6. So that's a little disappointing. And it's basically you got all the credit or you didn't get any credit. Some of you got a little bit of credit because you were really close, and then you would go and say something that wasn't true. So lysine is required to make beef steers grow rapidly. That is a true statement. My steer requires 10 grams of lysine a day, and I feed him 10 grams of lysine. Have I met his requirement? Why or why not? And so the key thing is I feed him 10 grams of lysine. If I said I supply 10 grams of lysine to his small intestine, then I could say for sure I've met his requirement. So you could say no, you haven't met his requirement. I said maybe because you're not really 100% sure, but you could say no. No is probably the answer that most of you defaulted to if you got the answer correct. And the reason is because ruminal microbes can alter the protein quality, thus it's difficult to say. So they could decrease the protein quality and you could end up with less lysine than the 10 grams, or they could add lysine and improve it, and thus you could end up more than the 10 grams. Some of you were more clever, and you said yes, as long as the lysine you fed is protected. And I generally counted that right because you did a good job of hedging and covering your bases. So the key thing is just make sure the lysine, you think about degradability, rumen degradable protein, DIP, UIP when you answer those types of questions. Okay.
I have a question on that one. Number 2.
Okie dokie.
Lysine is a non-essential amino acid, so
that's not true.
no. Okay,
No.
never mind.
Lysine's essential. Are you good? Yes?
Yeah.
Okay. Okay. The next one is the one that's also perplexing. So alanine is an amino acid found in significant quantities in the muscle of pigs. This is a true statement, right? Because it is an amino acid, and it is found in the muscle of pigs because all 20 amino acids are found in the muscle of pigs. My pig Wilbur from Charlotte's Web is depositing 5 grams of alanine per day in his muscle. That could potentially be true. What happens to Wilbur's ability to grow if I feed him 2.5 grams of alanine per day? Note, I'm currently feeding Wilbur 5 grams of alanine per day. And the answer that you're supposed to write is nothing. Alanine is a non-essential amino acid. Therefore, Wilbur can synthesize enough to meet his requirements. And so this was also somewhat alarmingly bad because you guys got a 1.77. And most of it was so many people told me alanine was essential, and it's not. And so a number of you wrote about its non-essentiality and then would still say that the pig's not going to grow. And so that was confusing. You got some points for saying it's non-essential, but then you lost some points for saying that you have problems. Oh no, what's going on? Come on. Okay, So the purpose of the numbers were basically, I had to put numbers so you could see how much I was changing it or not changing it. If they didn't have numbers, it would make it difficult to know that I was decreasing or increasing. I guess I could have wrote increase, decrease, but that gets confusing to me, so I used numbers. The numbers are arbitrary, they're made up. That's why I tried to define them very carefully. Okay. Okay, what do enterocytes do with amino acids once they're absorbed? And so this, if you look at the key, it's not written, the key is not written very well. I think of this in terms of like priority. And so the enterocytes can put amino acids into the blood. The enterocytes can use them to synthesize proteins, and the enterocytes can use them for energy. Almost everybody said they can put them in the blood. If you said that, you got 2 points. If you said they could synthesize proteins with them, if the enterocytes synthesize proteins, not the body, but the enterocytes synthesize protein, you got 2 points. And then if you use them for energy, the enterocytes use them for energy, you get 2 points. Okay, this is a question that I really liked, but it did not go well. And so what I did is thought we would use this as an educational moment. And I just gave everybody full credit for it because it was going poorly. And that was frustrating. Some of you got it right, but the vast majority, and even when you got it right, you didn't get it generally all the way right. Okay, so why is urea the most valuable to a ruminant, intermediate value to a horse, and of least value to a pig? The reason ruminants can really use it is they can use it to synthesize microbial crude protein, which can provide amino acids to the animal. When they synthesize microbial crude protein, they can increase carbohydrate usage and ferment more carbohydrates and provide more amino acids to the cow. So it's really, really a good thing. Horses are intermediate because they can use it in their large intestine. So it's going to come through the blood into their large intestine to synthesize microbial crude protein, which is important for utilizing carbohydrates in the large intestine. So you have to have MCP in the horse's large intestine to utilize carbohydrates. And so urea can be used for that. In the pigs, they're going to synthesize some microbial crude protein, but there's not a lot of fermentation. And as a result of there not being a lot of fermentation, it just doesn't really matter. There's not a huge use for it. It's not amazing. I think it was a struggle because I probably didn't teach it well. And so that's why I gave full credit. If you did it right and got the right answer, you can feel good and happy about yourself. But what I really want you to see is that urea is being used to synthesize microbial crude protein in the ruminant animal. It has more value because they can digest that microbial crude protein and use it as a source of amino acids for the animal. And the horse, it has some value because we can now use that microbial crude protein to utilize carbohydrates so they can produce VFAs so the horse can meet its energy requirement. And the pigs, again, not a lot of use. Okay, the last one was intended to always be a full credit question. Basically, I just wanted to see what you would write. And some of you did really well and did a really good job explaining why studying protein utilization is important. You talked about requirements, you talked about cost, you talked about oversupplementation, undersupplementation. It was more for me to just get a glimpse into your higher level understanding. Some of you didn't write very much and what you wrote wasn't great. So you might think about why you're actually studying what you're studying. Why are you doing this? What is the purpose in this? Why should you care? Okay, any questions on the short answer before we motor through the multiple choice? Everybody's good? Someone say hi just so I know that you guys can hear me.
We can hear you.
Okay, thanks. Okay. I spent a lot of time in this little spare bedroom talking to myself. So, which of the following can activate a zymogen? HCl can activate a zymogen, pepsin can activate a zymogen, trypsin can activate a activate a zymogen, and enteropeptidase can activate a zymogen. So I told you the last time we did one of these, you should like make a little matrix or a little grid to check off or circle the ones that are true. So A, B, C, and F are true. So A, B, C, and F. So J is the right answer. I guess it's going to be checked for me. So everybody good there? If not, speak now or forever hold your peace. Okay, which of the following can hydrolyze a peptide bond in the small intestine? Trypsin can, tripeptidase can, enteropeptidase can. So that's C, E, and F. So C, E, and F. So far I'm doing good. Okay, which of the following can denature a protein? Only HCl denatures proteins. Which of the following are produced by the enterocytes? Not HCl, not pepsin, not trypsin, not trypsinogen. So tripeptidase and enteropeptidase are produced. E and F are produced. Okay. Which of the following contains a peptide? HCl does not. Pepsin does. Trypsin does. It says peptide bond, right? Yeah, peptide bond. Pepsin does. Trypsin does. Trypsinogen does. Tripeptidase does. Enteropeptidase does. The reason they do is because these are all proteins. So B, C, D, E, and F. B, C, D, E, and F. Which of the following is absorbed by the large intestine? This question you could say the same thing. Which of the following is absorbed by the rumen? So it's going to be VFAs and ammonia. Urea is secreted by the large intestine into the lumen. So don't pick urea. Okay? So D and E, D and E. Which of the following contains no nitrogen? Like everybody got this right, so good job on you. VFAs. I mean, not actually everybody, but like 98%. Which of the following contains two peptide bonds? Tripeptides contain two peptide bonds. Which of the following moves from the gastrointestinal tract to the liver via the blood? So the gastrointestinal tracts, the whole deal, like the rumen, the stomach, the small intestine, large intestine. So amino acids, but not dipeptides or tripeptides because they're going to be cleaved in the enterocyte into amino acids. VFAs go from the gastrointestinal tract to the liver. So A and D, and ammonia, A, D, and E. Like the fat soluble vitamins. Is it a choice? Yes, good job. Which of the following is absorbed by the small intestine? Amino acids, dipeptides, and tripeptides, A, B, and C. And so we have A, B, and C. Which of the following is active in the stomach? HCl is active in the stomach, and pepsin's active in the stomach. Ooh.
So for that one,
Yeah,
so by active, it just means which one is interacting or in the stomach? Because I was confused because I thought active was only like pertaining to enzymes and stuff. So I didn't think the acid.
Yeah, it's just something doing something.
Okay.
Does that make sense?
Yeah, I was just thinking in terms of like being activated and stuff. So that's why I only said pepsinogen.
Yeah. Okay. I don't have a, no, I do.
Hello.
Yes.
I have a question for the denature protein. So why the answer would be only the hydrochloric chloride?
Because it's the only one that technically denatures proteins is hydrochloric acid. The others break the bonds, break peptide bonds.
So pepsin didn't denature the protein?
It does not denature the protein.
Okay, gotcha. Thank you.
You're welcome.
Can you define denaturing in your words, please?
Breaking the secondary, tertiary, and quaternary structure of a peptide, disrupting it. Starting to feel like my defense.
Would you say like unraveling the protein to make it just like a string of amino acids?
Yeah, yes, yes. Jody scared me.
Why does it scare you?
It just scares me when anyone talks, because it's quiet. Okay, everybody good? I can't even see you guys sigh or roll your eyes, so it's very frustrating. Okay, please rank according to the amount of MCP produced. So a cow produces the most MCP, then a horse, then a pig. Okay, and that should just, you think about how much fermentation occurs, and you go for that. That says nothing about utilization, right? If we're looking at utilization, then it becomes choice B, because the cow can use it, whereas the horse and pig cannot. That might be a question, I can't remember. Please rank a cow according to the amount, good job, me. Please rank according to the amount of MCP absorbed. So the cow is going to absorb the most, the horse and pig are going to absorb none. So they're equal, they both absorb 0. Please rank according to the amount of endogenous urea to synthesize microbial crude protein. Endogenous urea is urea recycled. So urea is secreted by the body via the mouth or the blood. However, so the cow is going to use the most, then the horse, and then the pig. That goes back to that short answer question we talked about earlier. Please rank according to the importance of having the proper amount of each essential amino acid in the diet. So you have to think about who's who and what's what. And so the horse and pig are equal because they're both monogastric, so they have to have the essential amino acids in their diet, whereas the cow does not. Please rank according to the importance of having the proper amount of each non-essential amino acid in the diet. Here they're all equal because we don't have to necessarily have every proper amount of non-essential amino acid in the diet, because the animals can synthesize their own non-essential amino acids, thus meeting their non-essential amino acid requirements. Please rank according to the importance of having the proper amount of each essential amino acid arrive at the small intestine. So this is the small intestine. I feel like this series of questions is really similar to what we did on quiz 1. And so hopefully that helped you work through that. And so essential amino acids arrive at the small intestine. They should all be equal because they all need them to show up at their small intestine to meet their amino acid requirements. Please rank according to the importance of having the proper amount of DIP in the diet. The cow is the only one who actually requires, or even we think about DIP, degradable intake protein, is in the cow, so the cow is greater than the horse and the pig. The others just have to have digestible protein. And that's something that on the short answer, a number of you would call this digestible intake protein, which you need to call it degradable intake protein. Okay, please rank according to the number of compartments in their stomach. And so the cow is greater than the horse equals the pig. I put that in there just in case you were having problems. It would maybe help you figure out how to answer those questions. And so hopefully that helped. Maybe it didn't, everybody got it right. Then this question, I gave everybody full credit, even if you didn't pick the right answer. Even if you picked 1898, I still give you the full credit, but that would make me 143 years old. So that seems unlikely. And so a number of you picked 2008, which would make me 33 years old. So I appreciate that. And then a small fraction of you who said I did not attend Texas A&M University, which kind of makes me laugh because you can see my ring when I teach class or when I make videos, whatever you want to call it. Okay, any questions on the exam?
Question 22. Yeah, that one.
Okay, lucky.
Why does a horse not need more essential amino acids in their diet than the pig? Like, a horse is more active than a pig. Wouldn't they need the more amino acids?
So it's not the amount, it's the importance of having the proper amount. It's not saying the pig needs more than a horse or the horse needs more than a pig. because what you're saying kind of makes sense. The horse is more active, but like my horse is neither active nor does he grow. So an actively growing pig may actually require more amino acids than a horse, more in terms of grams per day, especially if I had a mini pony or whatever a mini horse is called. I don't, but I do have a horse that doesn't do very much. Does that make sense? So that's why I worded it the way I tried to word it. So it wasn't, I don't want you to think about it in terms of a horse requires the same amount of lysine per day as a pig. It's just that they get the proper amount for them. Does that make sense?
Yes, when you explain it that way, it does make sense. I was just thinking of it in the wrong way, I guess.
You're thinking of it in grams per day.
Yeah, thank you.
Which is hard, right? Because, you know, like, depends on the horse and the pig and the cow. And I could create an infinite number of scenarios that would be terrible. So, yes. Other questions?
I have a question about the comparison questions in general.
Yes.
Like on the previous exam, the comparisons were more explicitly stated, like they were in the SI notes, and we went over them like more exactly.
I told you the answers before the test.
Pardon?
I said the answers more explicitly before the test.
Yes, and so this I found harder for me because I kind of had to piece the information together more rather than having it like just memorized. So what's your advice when we go about this to not overcomplicate them?
So my advice would be to, and this is always my advice when it comes to these, is to, and the reason I didn't maybe go into them as much depth is, one, it's harder for me to talk about things like that by myself, and two, you guys have the notes in front of you. So I think you should and you have unlimited time, right? And some people took unlimited time, like an amazing amount of time. And so I guess I would say really, really slow down and think about what the question is saying. And so I'm reading this book, and you guys don't care, but I'm reading this book on how you think and how people think. And there's two ways you think. One's like how you think quickly and just respond to what's happening. The other is like you're more like actually sitting down and thinking. Like if I asked you to multiply 87 times 26 in your head, you'd really have to hunker down and think about that. And I would encourage you to, and you guys can sigh and roll your eyes, and that's fine. Think about these questions more like multiplying 86 times 27. Like really sit down and take some time and think about them as much as possible. Think about how a horse uses essential amino acids, where they come from, how a pig uses essential amino acids, and how a cow uses essential amino acids and where they actually come from, and then answer the question. I also felt like because we did the quizzes kind of introduced the importance of this concept, the essentiality of amino acids in the diet versus showing up in the small intestine, and the differences between ruminants and non-ruminants. I felt like you guys should have maybe been able to draw some capacity to answer these questions from that. Does that make sense?
Yes, it does. Thank you. I found that very helpful.
Okay. And so and if you didn't see the last review, the last time we did one of these, you should go back and watch it, because it explains how I would eliminate possibilities. Because one of the things that makes the way I ask these questions difficult is the large number of choices. So if you basically make something where you can like cross out the one, oh, it's going to cross them all out. Maybe it doesn't work. But if you can cross out the ones you know to not be true and then kind of whittle it down that way, I would do that, because you have, like I said, lots of time. And I know it's not unlimited because you have other things you're doing, and you're increasingly busy with this online class stuff. So just try and go through, and if you have time, go back and watch that so you can figure out maybe how to cross things out as you go, and that might be useful. Other things?
I had a question about the please rank according to the amount of MCP produced. So in the lecture, you said that in the horse, it's the most extensive. So does that not mean that more MCP is produced in the horse?
The large intestine is the most extensive, but the cow still has the rumen in front of it.
Okay.
So like if I said, so this would be something I would do, right? Like, because this is what I would do on the final, is you guys all have this, you guys will think about this, you'll be like, oh, he did that, what a pile. So what I would do on the final is say, please rank according to the amount of MCP produced in the large intestine.
Okay.
And then you would need to go, you would pick option C, right? Where to go? You would pick horse is greater than cow is greater than pig. Does everybody see that? Does that make sense?
Yes.
Okay, because that's the way. That's what I do.
Dr. Wickson?
Yes, Sabrina.
So go back to the question the lady just asking. So do you say if we focus on the large intestine for the fermentation about producing the amount of MCP, is going to be horse the largest and the cow is the next and the pig is the last, right?
Correct. Yes, ma'am.
Okay, thank you.
And so like, you haven't probably watched them because I just posted them. So on the lipids, we're going to talk about microbial phospholipids, and microbial phospholipids and microbial crude protein are basically part of the same thing because they're both part of the microbe. So anything you can ask about microbial crude protein, you can ask about microbial phospholipid. And so, because they're like the same, they're not the same thing, but they're part of the microbe. So if one increases, the other increases. If one goes down, the other goes down. So be thinking about microbial phospholipid as a substitute for microbial crude protein. Okay, what else? Everybody's good? Everybody's satisfied? Not happy, but satisfied? Like a Snickers? Okay. Was someone going to say something? Okay, I'm going to, just to capture this concept here. So I became worried that we're going to have too much to do next week. So I got rid of quizzes 5 and 6 and just gave you the points for them. So don't worry about quizzes 5 and 6. We'll just have quizzes 7 and 8. 7 will be over lipids. The second part of lipids. Quiz 8 will be basically an evaluation of the course. So if you do it, you get the points. And then you guys have the papers, but don't worry about quiz 5 and 6 because I feel like we just have too much going on, and I'm guessing that a number of other classes are doing the same thing. Like we pushed everything to the end, and now it's just way too much. So good.
Dr. Wickster?
Yes, Sabrina.
So about exam 4, is that still the same day? You didn't change it. You're not going to change it, right?
When's it due? I can't remember off the top of my head. I can look.
It's next Friday.
Yeah, so what I'll probably do is actually open it up on Friday, and you guys can have till like Sunday night to be done with it.
Okay, thank you.
If that's okay.
It should be fine, I guess.
Okay. I was going to open it up maybe Thursday night, and you guys can have till Sunday or Saturday night or whatever. I don't really care like how long you have. It doesn't matter to me. The one thing I will say though is if you decide to a couple people cut and pasted text from books, and that's not a good idea. So just don't do that. Okay? Anything else before we motor on? Any other questions?
Is the exam 3 activity and exam 4 activity just going to be the same as the exam 3 one?
Yes, the exam 4 activity will be virtually identical, except we'll substitute the word lipid for protein. So you'll draw 3 lipid pigs, 3 lipid cows, 2 enterocytes, actually 4 enterocytes because the lipid enterocyte's different for the cow and the pig. So you'll have 2 enterocytes for each of them. And then we'll probably not pick a movie, we'll probably, or a book, we'll probably pick something else. So yes.
Okay, and can we use the same ones from like the ones with the timestamp on it?
Yes.
Okay, thank you.
You're welcome. Anything else? Okay, I'm going to close this. This is going to go away.
Will you open the exam so that we can go back and look at our answers?
I believe it is open.
Okay.
At least people have said it's open.
Okay, thank you.
Is it open?
Yeah, it's open. I was able to look at my answers. You just have to click on your grade that you got, and it'll take it to you, and it'll take you to it.
Thank you.
Okay, because once I was done grading it, I let it be open. That way you guys could go look, because there's no secrets. Okay? Okay. Anything else before we move on? Okay. And so what I thought we might do, because maybe this will be good, maybe it won't, is today we're going to draw the lipid pig, even though you guys probably haven't thought about it at all. I think maybe going through and having me draw it real time might be useful. And if you want to draw it, that would be good. And then we're actually going to move the Zoom to probably Monday night to allow us to do the cow in advance of when you need it for the exam activities and the test. Now the videos of the pig and the enterocyte and all that jazz already exist. Okay, I uploaded them today, and so we should be good. Everybody okay with that?
Yes.
Okay. Thank you, Ms. Johnson, for responding. Okay. And you guys can see the pig pretty well, I assume, because it's the only thing on my screen. So it's as big as it can be. Okay, what we're going to do is we're going to feed the pig tag. And so feed your pig some tag. And it's going to be a little different when you guys get to the ruminant. The ruminant's actually going to, we're going to feed some other lipids that aren't tag, but tag being triacylglycerol. And so we feed it, goes in to the stomach. And so we're going to have in the mouth, we're going to have a decrease in particle size. And we're going to have emulsification. Okay, and emulsification is basically, in this case, just the chewing. And the other thing we're going to have showing up in the mouth is lingual lipase. And if you guys all start leaving and you're the last person and you decide to leave, let me know so I'm not just talking to myself. Okay. In the stomach, we're going to have gastric lipase. And both lingual lipase and gastric lipase can operate at a low pH of the stomach. So that's something kind of unique about them, is that they function at the low pH of the stomach. And what they're going to do is they're going to take this tag we have, and we're going to produce DAG plus a free fatty acid. But predominantly, most of the fat is still going to be present as TAG. The other thing occurring in the stomach is physical emulsification. Okay, and so that's a good thing. And what's going to happen then is we can basically, wrong color, take all of this and drag it all the way through the small intestine. And so in the liver, we're going to have bile production. And in the gallbladder, we're going to have bile storage. And bile stored. And then bile is going to be released. And so bile provides for chemical emulsification. Okay. And also happening in the small intestine again, as the food moves into it or is propelled through the pyloric sphincter, we have physical emulsification. And in the notes, we called this phase 1 of lipid digestion in the small intestine. So phase 1. Okay. The other thing that's going to be happening in the small intestine, and this is again, just like in protein, mediated by the SNI cells releasing secretin and CCK. We're going to have the addition of buffer. And then we're also going to have the addition of buffer from we're going to have the addition of buffer from this pancreas. Okay. And then we're going to have the secretion by the pancreas of an enzyme and the enzyme's friend. Okay. And the enzyme is pancreatic lipase. And the enzyme's friend is procholipase. Okay. And so they're both going to be secreted right in like microtonight. The pancreatic lipase and the procholipase are both secreted into the duodenum, and procholipase is activated by colipase, or is activated to colipase by trypsin. What intestinal enzyme is required, like a step back, for procholipase to be activated to colipase, and that is enteropeptidase. You have to have enteropeptidase to activate trypsinogen to trypsin, so you can activate procholipase to colipase, so you can start to digest lipids. Okay, so really keep that in mind. That's an important thing. What we have with these enzymes is phase 2. And we're going to draw a little picture of phase 2. We're going to draw a fat particle. We're actually going to draw 2 of them. The green represents the bile, so we'll draw one there, and then we'll draw one over here. Okay, and the one right here is filled primarily with TAG coming from the stomach. And so the bile is coating this, surrounding this, it's stabilizing it, allowing it to remain emulsified. That's a DAG and a free fatty acid, just to capture the idea that at least some TAG is broken down in the stomach, bilingual lipase and gastric lipase. Okay, and so we have the colipase. Colipase creates an anchor. It's basically a spot It creates a spot. It has a hydrophobic region. So it's a protein with a lot of hydrophobic amino acids. And those hydrophobic amino acids like to interact with the fat droplet. So it creates an anchor. And so it associates with the fat droplet. And then by creating an anchor, it creates a place for pancreatic lipase to attach. Okay, so colipase basically creates a spot for pancreatic lipase to attach. And then pancreatic lipase is going to hydrolyze those ester bonds. And what we're going to end up with is MAG and 2 free fatty acids. Okay, and so basically all of the tag or DAG or whatever's present is going to be completely hydrolyzed to MAG and free fatty acids. And just in case you don't know or can't remember, it might be a good idea to draw a tag. And so a tag is a triacylglycerol. So it's a glycerol backbone with 3 fatty acids. And our pancreatic lipase, in concert with its good friend colipase, is going to produce MAG, monoacylglycerol. It's actually 2 monoacylglycerol because the fatty acid will be at the 2 position. Okay, and then plus 2 free fatty acids. Okay, and so to create MAG from tag, you're going to break 2 ester bonds and create 2 free fatty acids and a MAG. And that's phase 2. Phase 3 is absorption. So what we'll do is we'll draw an enterocyte. Okay, so we have an enterocyte. And what's actually going to be absorbed?
Get it back over, please. We can't.
Oh, sorry, thanks. It's a good thing you're here.
We're still here and listening. We got you.
I know, I can see 24 of you, so I keep looking every now and then. If it goes to 0, or if it goes to 1, then I'm out because that's just me. And so basically, kind of depends on when I teach, but we're going to absorb these fatty acids and free fatty acids with less than or equal to 10 carbons. It's really small. Are basically going to be absorbed and go straight through the enterocyte. And they're going to go into the blood. And in the blood, they're going to bind to albumin. And this is a different albumin than the albumin in the egg. And then that is going to go to the liver. So short chain fatty acids less than or equal to 10 carbons. Sometimes I say less than 12 carbons, but less than or equal to 10 carbons is the same thing because in nature, fatty acids have even numbers of carbons. Those are going to go straight to the blood and be done. Free fatty acids with greater than or equal to 12 carbons, in contrast, will be absorbed, and they will be combined with the MAG that's been absorbed to form TAG. And so I posted the video of the enterocyte today, so you can go and watch and see what's actually happening. What's happening is this TAG accumulates in the endoplasmic reticulum, and then B48 is a protein that's attached to the TAG, and it basically says, I am an exogenous lipid, and then it's going to go to the Golgi apparatus. They're going to stick a carbohydrate on there, and then it's going to be exocytosed. And when it's exocytosed as a chylomicron. And a chylomicron is how exogenous lipids are transported in the body. And this is a big difference between this and everything else we've done in class, is the chylomicron actually does not enter the blood, it enters the lymphatic. So way back in January or maybe early February, when we were talking about the small intestine, we said each villus has a central lacteal, which is part of the lymphatic. And so the chylomicron enters that central lacteal and then enters the lymphatic. And it basically hangs out there for 30 minutes to 3 hours, where it then enters the blood. It does not go to the liver. It's going to go to muscle and adipose. And the muscle and adipose have an enzyme. We'll do it in purple because it's an enzyme. And that enzyme is lipoprotein lipase. And lipoprotein lipase is unique in that it identifies the B48, which you guys learn about when you go look at the enterocyte. It identifies that B48 and can attach to it or associate with it. And so what lipoprotein lipase is going to do is produce DAG plus a free fatty acid, and those get absorbed. So they get absorbed out of the blood into the adipocyte or the muscle. And so basically you can think of this chylomicron as a balloon, and you're basically slowly sucking all of the tag out of it as DAG and free fatty acid using lipoprotein lipase. And then you end up with a deflated balloon. And this deflated balloon is a chylomicron remnant. So lots of new words this time. Great words. So we have chylomicron remnant, and that chylomicron remnant is going to go to the liver, and you guys can't see that. Goes to the liver is going to pull it out and metabolize the chylomicron remnant. It has protein, carbohydrates, cholesterol, some other things that the liver is going to pull out of this blood. Okay? And so that's basically how you absorb lipids, or how the pig absorbs lipids, and how you absorb lipids. In the ileum, can you guys see it? Nope. In the ileum, we have bile, and the bile is going to get absorbed. And I can't remember if I talked about this, but this is how, if you have someone in your life who has high cholesterol and they're supposed to eat oats, like Cheerios or oatmeal, basically what you can do is you can trap bile on the oats or the Cheerios, and they'll get excreted in the feces with the fiber. And then bile is made from cholesterol. So instead of recycling your bile, you're going to have to make new bile, so you use your cholesterol up. This bile gets absorbed in the ileum, and it goes all the way back to the liver. So zoom out. The bile is going all the way back to the liver, and this is known as enterohepatic recycling of bile. It's a way to save cholesterol. So you can keep cholesterol that way. Okay. Let's probably be the most, I don't know. It's an important thing that I'm about ready to say. Some of the lipids are undigested. And they can be excreted. The other thing that can happen to them is they can be hydrolyzed. And hydrogenated. Okay, and hydrolysis and hydrogenation are microbial activities. Okay, and so hydrolysis, that's basically bringing the fatty acids off of the glycerol backbone, And hydrogenation is taking unsaturated fatty acids and saturating them. Okay? There's only really potentially one thing that can be absorbed. And so when you do this hydrolysis, you end up with the glycerol. You end up with the free glycerol, which the microbes ferment into VFAs, and the VFAs can be absorbed. Okay, so really the only thing lipid digestion wise you're going to absorb in the large intestine is VFAs. We also have the synthesis of MPL, and MPL gets excreted, and MPL equals microbial phospholipids. Okay, and so basically, if you go and watch the Rumen video, or we do it on Monday evening or whatever, and basically everything that happens in the rumen can happen in the large intestine. It's just going to happen in a very, very small amount in the pig, more in the horse than in the pig, okay, because we have more microbial activity. But undigested fat can be acted on in the large intestine. Okay, and so I just wanted to go over that in like a real sense, and then see if you guys wanted me to clarify anything before I said we're done. So, do you guys have any questions?
So I remember you saying something about how like eating fat slows down the rate of passage. Why is that exactly? I'm a little confused on that.
Okay, so basically your ileum, so the end of the small intestine, has sensing cells, tasting cells, that can identify the presence of fat, and the body really wants to digest fat because it contains a lot of energy, and throughout time, and most animals are still deficient in energy, they want to make sure they digest all the fat they can. So if the fat shows up here at the ileum, that sends a signal back to the stomach to slow down the release of food, because what you want to do is make sure you're digesting everything. And so another way to kind of think about it is anytime you start trying to digest protein and lipids, the release, the CCK and the secretin and all of that activity is really upregulating the pancreas and the small intestine, but it's also sending a signal back to the stomach to slow down how fast food's leaving the stomach. So if you consume fat, your body's just basically trying to slow it down because it's hard to digest. And one of the reasons it's hard to digest are difficult to digest because they are hydrophobic. And most of the digesta in the small intestine or the stomachs basically exist in an aqueous or a water environment. And so that makes it hard to digest lipids because everything's built to be in water. And so you really struggle, or the pig really struggles. Cattle struggle even more to digest lipids than pigs. They're not good at it. Horses are pretty decent at it, and so are pigs, but cows aren't.
Dr. Rickson.
Yes, Sabrina.
So do we need to exactly know like how it slowed down the rate of passage in the small intestine?
No, ma'am. You just need to know that lipids slow down the rate of passage.
Okay, thank you.
You're welcome. Other things? Is there anything you guys want me to do that I didn't do?
I had a question about when you were saying were you saying that the MPL is the horse is better at that than the pig, or what were you saying with that?
Okay, so we kind of talked about it a little bit at the test, right? So if we want to think about a microbe, so we're going to draw a microbe, and it's going to look like everything else I draw. It's a circle, right? And so this is a microbe. And that microbe contains MCP and MPL, right? And so in the horse, I have more microbes than I have in the pig. So the horse is always going to produce more MCP and more MPL than the pig. So anything you've learned about MCP, you can basically apply to MPL. Okay, the more microbial crude protein you have, anything that stimulates microbial crude protein production is going to stimulate microbial phospholipid production. And so the horse has a much more extensive large intestine and cecum, so we expect greater microbial crude protein production, so we expect greater microbial phospholipid production. I introduced this thing on the ruminant that's a little difficult to understand, and that's negative digestion. A negative digestion is the net appearance of a nutrient. So we'll say the pig is really good, which it is, really good at digesting lipids. And I have 2 lipids left, okay? When I arrive at the large intestine, the feces might have 6, okay? And the numbers mean nothing, they're to illustrate a point, okay? And this increase from 2 to 6, basically the 4, the amount it increased, is the synthesis of MPL. Okay, because the microbes can synthesize microbial phospholipid out of, from carbohydrates and energy and them growing and doing their thing. So you can have the net appearance of lipids in the feces versus what showed up at the large intestine, making it look like you have negative digestibility in the large intestine. And so with the horse, you might expect it to be even more, right? Say the horse has a 2, and then this might be like a 15 or something, because the horse produces that much more microbial phospholipid. Maybe it's 20. Okay, so negative digestion is the net appearance of a nutrient. Okay, if you guys think really hard, you can come up with another area where we have negative digestion, and that's microbial crude protein. And so you can actually have more protein show up in the feces than showed up in the large intestine. When the digestum moved from the ileum to the large intestine, you can have more microbial protein, so you can have negative digestion there as well. Does that make sense, Megan?
Yeah, thank you so much.
You're welcome. What else do you guys need? Nothing? No questions? Everybody's good?
I'm good.
Okay. Okay. Well, let me know if you need anything. All the lipid videos are posted. So we'll do a Zoom on the cow maybe Monday night, and then we'll be done with lipids. I'll make one more video on energy, and then we'll probably be done with videos. So I don't.
Dr. Rickshan.
Yes, Sabrina.
I just have a quick question. So for the microbial crude protein, is that going to be digested in the small intestine as well?
In the pig?
Yeah, or I mean for the cattle.
The only place microbial crude protein or microbial phospholipid is digested is in the small intestine of the cow.
Okay, so you only digest, it didn't absorb, right? It didn't break down into like amino acid or
Yes,
something else.
it'll be digested and absorbed.
Okay.
It gets broken down all the way down.
Oh, okay. All right.
Okay. And so will microbial phospholipids.
Oh, really?
Yes. You don't know that yet, but yes.
Okay, all right.
In the cow. Only in the cow.
Okay.
And the horse and the pig, and the horse and the pig, they both excrete them.
Oh, all right. Yeah, I figured out something. Thank you.
Okay, good. That's why we do this, is to figure out stuff. Okay. Any other questions? Okay. Well, we can be done. You guys have a good Thursday night and a good Friday and a good weekend. And I will talk to you hopefully on Monday. If you have questions, you can email me, put them in the group me, or whatever you need to do. Okay. Does someone, oh no. I'm not very good at the chat thing, guys. Okay, that's nothing. Okay, cool. Bye, guys.
Dr. Wickersham.
Yes, Mackenzie.
So we're just meeting Monday instead of Thursday, not both days, just Monday.
Probably because I don't know that Thursday will do much good by then.
Okay, I just wanted to clarify. Thank you.
You're welcome.
Good night.
Night.